In this video lecture, I will explain a C program for decimal to binary conversion. What is decimal number and what is binary number? So decimal number base will be 10. So digits from 0 to 9 will come, and for binary number base is 2. So 0 and 1 will come. So if my input is 13, so this is the decimal number, my output should be the binary equivalent of 13, that is 1101. So now we will see how to convert a decimal number to binary number. So the number, whatever number is given to you, what we should do? We should divide the given number by 2 until we get 0 as the quotient. So here 13 is the number given to us. What we should do? There are two things, quotient and remainder. So we need to divide the number by 2 and take the quotient and remainder until we get 0 as the quotient. So when we divide 13 by 2, remainder we get 1 and quotient we get 6. Then next time I will be taking 6 as a number. So now 6 if divided by 2, the quotient is 2 3s are 6. So we'll get 3 as quotient. And since 6 is divisible by 2, so remainder will be 0. And here also if when we divided 13 by 2, so 2 6 are 12. So quotient will be 6 and remainder, because we will get 1 as remainder. Now the next time we will be taking 3 as a number. So 3 if I divide by 2, so 2 1s are 3. So quotient will be 1 and remainder also will be 1. And then next time the number considered will be 1. So 1 when we divide by 2, quotient will be, because this is less than 2, so quotient will be 0 and remainder will be 1. So we have to stop here because we have to divide the number until we get 0 as the quotient. So here we got 0. So that means we need to stop, and then we have to write the remainder in the reverse order. So we have started from here. Now while writing the number, we should write in the reverse order. So 1 1 0 1, that will be the answer. So now let's take let's see how to write a program for the same decimal to binary conversion concept, and by taking the example. So here this is the C program which is written using function concept. So what we have done here, this is the function prototype, and then this is function prototype, and this is function call, and this is function definition. Okay, so if we write function definition before main, then this prototype is optional. Otherwise, if I'm writing the definition after main function, we need to include function prototype. And we have used the header file stdio.h that we will be always using, and mat.h because we'll be using applying some mathematical concept here, or mathematical library function we'll be using. So that time we should include mat.h. Okay, and then here we are seeing this is the name of the function convert, and then we will be passing the number. Suppose my input is 13, so output should be 1101. Okay, so this 13 will be the number which we want to input. So that we are passing int here, and because by decimal to binary conversion, sometimes we may get very big number also. So the data type it's better we take long. Okay, so the return type will be long. And here in main function, we have declared the variable n and bin. So n is the number which decimal number which user is inputting. So enter a decimal number. Suppose user has entered 13, and then this scanf function will take the input from the user, and this is the function call. So convert n means 13 will be copied. So here bin is equal to convert n means 13 will be copied. So this 13 will come here, this 13 will come here, and now we will see the actual decimal to binary conversion logic here in the function definition. And once this is done, the value will be returned here. The same value means 111101. After the calculation, it will be returned here, and that binary number at the end we are printing the value. So now here this is the logic for decimal to binary conversion. This is the logic. So here what we are doing, initially bin is equal to 0. So bin is equal to 0 we have assigned, and then remainder we have taken the variable remainder I is equal to 1. So remainder, because we need to calculate the remainder, and I for loop variable we have taken, and then again we are checking the condition n is not equal to 0. Until this is not equal to 0, we will be doing this calculation. So here there is one thing, n is not equal to 0. This is the condition. Until this condition is true, I mean when the condition becomes false, we will come out of the while loop, and then we are calculating remainder using n percentile 2, because we are dividing the number by 2 until the quotient becomes 0, right? That is the logic. And n is equal to n by 2, that we are seeing for calculating the quotient, and then there is a value of I, and the actual calculation bin is equal to bin plus remainder into I. Using this formula, we will be writing the binary equivalent of decimal. Okay. Now here the input given is 13. So 13 is not equal to 0. Condition is true. And then 13 percentile 2. What remainder we will get? Remainder we will get 1. And then quotient 13 by 2 we will get 6. And I value initially it is 1. So bin value will be bin, and bin is initially 0. So it will be 0 plus remainder is what? 1 into 1. So this will be 0 plus 1 will be 0 plus 1 into 1, it will be 1 only. So then we will this bin will be 1. And then next time which number we have to take, because what we are doing, remainder is equal to n percentile 2, and then n is equal to n by 2, and bin is equal to bin plus remainder into I. So next time the number, because n is equal to n by 2, so next time the number will be the 6. So now we'll say 6 is not equal to 0. We will check the condition, and when the condition is true, then only we will these steps will be executed. So then 6 percentile 2, remainder will be 0, and 6 by 2 quotient will also be quotient will be 3. Okay, and I value, see we are saying I is equal to I into 10. So now I was 1, so I value becomes 10 now, and now bin will be bin plus remainder into I. So what is bin? 1, and what is remainder? 0, and what is I? 10. So this will be 1 only. And next time what will be the value of n? Value of n will be 3. So now again we'll check the condition. 3 is not equal to 0. Condition is true. 3 percentile 2, what will be the remainder? Remainder will be 1. And 3 by 2, what will be the quotient? The quotient will be 2 1 ja 1. So 2 1 ja 2. So here the quotient will be 1, and I will be I into 10. So it was 10 in the previous step, so it becomes 100, and that bin will be bin plus, so bin in the previous step bin is 1, and remainder is 1 here, and what is the value of I? It is 100, so it will be 101. Okay, and next time what will be the value of n? The value of n will be 1. So 1 is not equal to 0. Condition is true. What will be the remainder? 1 percentile 2 is what? Since 1 is less than 2, so remainder will be 1 only, and 1 by 2 the quotient will be 0, and value will be I into 10. So 100 into 10 will be 1000. So bin will be bin. So previous step it is 101 plus remainder is what here? Remainder is previous step here in this step remainder is 1, and into what is the value of I? I value is 1000. So this will be 1 1 0 1, and next time the quotient 1 0 is equal to 0 is not equal to 0. The condition becomes false. So we will come out of the while loop and return bin. So return bin, this is the last step. Return bin means this bin value, this value 1101 will be returned to the this value will be returned to the function call, and then the value of bin is printed. So hope you have understood the concept of decimal to binary conversion. Thank you for watching.